So here is the pause symbol slide. I don't think there's any pause symbols in it. I cannot remember, but if there are, pause, take whatever notes you need and go on. If there aren't any pause symbols, just pause as you need to in the video. But our objective, the student will be able to use geometry to build a bridge. This will be done through group work, critical thinking, and a stress test. So it's actually a pretty fun activity. We're going to give you guys some straws, and you're going to take the straws and you're going to put together and you're going to make bridges, and then we're going to test them through some weight. That's the stress test part. So we're going to put weight on it to see how easily they break or how hard they break. The ideal goal is to put as much weight as you can on top of the bridges. But when we're building our bridges, we're going to be using straws. And something else that if I don't tell you later, the best group that holds the most weight will win a candy bar. I always do some sort of bribery in this to make everyone try. But the best group will win a candy bar with our little straw bridges. Okay, we already went over the objective. Students will work in groups of 2 and 3. We should have mostly all groups of 2, but we'll have a few groups of 3. So how this works is if we have someone that's absent, they'll be added into a group. So that would be one of the groups of 2. One of the groups of 3. And then say like there's a spare person, they'll be in a group of 3. So what we're going to do, the groups of 2 will make their bridges. These bridges will be tested after they're built. We're going to put weights on top until they break. It is due on Friday, so you're only going to have a few days to work on it in class. The packet's due on Friday. We're testing on Thursday. This activity will help with measurement, geometry, critical thinking, and working in groups. Students will be able to use 50 straws. Tape's the only thing that can hold them together. You can cut the straws. The tape can't be used as a building material, and the sizes are as follows on the bottom. So those are the 5 rules right there. So the rubric. The rubric's kind of big. I'm going to try running through it, but basically the drawing and planning. As long as you put some effort into it, you're going to get the full 10 points. So what happens is some people that don't put effort into it, you kind of tell, like, they follow directions. You guys, you know what it is. Draw a picture. If the picture looks good, it looks like you tried, you're going to get the full points. If it goes down less and less and less, you can get 8 points, 5 points, 2 points, and 0 points. 0 points is if you don't turn them in. So, or it's not done. So if you put a little bit of effort, you'll get 2. Next, building the bridge. As long as you follow all the rules, you're going to get the full points. This is a very easy 10 points right over here. And it's 20% of your grade is just following the rules. Say you only follow 4 of the rules, so I don't know how you do that. Usually this is like someone that decides to just start wrapping it in tape. You're going to break one rule that way. So it should be pretty easy to follow all the rules. So there's 10 points right there. Next, the stress test. I'm going to go backwards with this one. So if your weight doesn't hold any weight, so meaning if I put the lightest weight, and that's 1.25 pounds, I think is the smallest weight I have. If I put that on it breaks immediately, that's where you only get the 1 point. If it holds that 1 pound weight, you get 2 points. Holds 2.5 pounds, you get 5 points. 5 pounds, 8 points, and 7.5 pounds is 10 points. At the time of this video, I think the largest we had someone do was 28 pounds. So, but hey, who knows? Between now and when the video is made, we might have some more people do bigger weight. And next, as long as you're not answering a 3-word question, 3-word answers for the conclusion, you'll get more than 6 points for 3-word answers. 8 points is it seems like you did it, but you rushed. And to get the full points, you answered the conclusion questions thoroughly, and it looks like you put some effort into the conclusion questions. So that's that. It shouldn't take you too much time. I mean, it shouldn't be too hard to get an A on this. Read through it. If you have any questions, feel free to ask me in class, and I will answer any questions that you have. But overall, this is going to be a fun project. This is what I'm using to grade you guys on it. So good luck on your bridges. And remember, follow all the rules. Do the conclusions. Make sure you do the planning and everything else you need to get yourself a nice, good A on this project. So our conclusion. These are the few questions we're going to be looking at through the conclusions. What worked? What did not work? What I would change? So what worked? Again, if you want better than an 8, which is a A for that section, but what we're looking at is what worked. So my bridge held weight would not be a good answer over there. So more than 3-word questions, what worked, what didn't work, and how you do it. But how you build your bridges. So I'm going to give you a little bit over here how to build your bridges and what to do and how to be successful with your bridge building. So in a second, you're going to see that it's going to pop up with the next part. And first, compression. This is something that's going to be on your pre-test and post-test. Compression is the idea of putting weight on something till it compresses, till it squishes. So if you notice, you put a weight on the straw kind of squishes out and pops. We're actually compressing that straw. So that would be compression right there, would be pushing something together, adding weight until it pushes together. This isn't a scientific term, probably. I know they'd have better, but think about compression. What's going to happen to that straw when you put on weight on it? Tension is actually the opposite of compression. So even though you can see that I'm putting the weight on and it snaps, actually what we're looking at it is tension is actually pulling stuff apart. So it's taking something and pulling it apart. So what usually happens with this is your straws actually pull apart from the rest of the bridge. So these are weak shapes. They're not like weak, it's just they're not going to hold as much weight. And here's some examples of what happened with the weak shapes and what I've seen in the past of what people do and how the weak shapes do affect their objects. So if we put a weight on top of our left little box over there, what happens is it might slowly start shifting to one side until it kind of breaks and falls. Same thing with this rectangle. If you have a really long rectangle and you put weight on it, it'll start squishing in until it pushes through. Next, we have our strong shapes. Our strong shapes are the shapes that we're looking at that we want to put as many as possible in the bridge. And you're going to find out later why strong shapes are strong when I ask you some questions to make you think outside the box later, but why strong shapes are so good. But right now, if we put a weight on top of either of these, what happens is the force doesn't go to one side or the other, or doesn't squish into the middle. It just goes down the sides. So it equally pushes the weight. Next, how to make a weaker shape stronger. So this isn't too hard. All we have to do is basically try to make these into either triangles and circles. Triangles or arches. So if we put a line through that square, it makes into 2 triangles. If we put 2 lines in that rectangle, it makes into 3 triangles. So now we have those strong shapes placed inside our weaker shapes. So let's think outside of the box. So if we just put a bridge with straws all the way together like this, it's probably not going to hold any weight, or not too much weight. It might hold that little amount, but what's going to happen is you're going to put the weight on, and the weight's going to start pushing it through, and it's actually going to buckle and snap, and your weight's going to fall off. So how can we make these bridges stronger? What we can do to make our bridges stronger is we actually have to add those stronger shapes into our projects. So for example, this one over here, the first left one, what we're going to do is we're actually going to make this weaker shape a little bit stronger. Sorry, I have to wait for the video to catch up to me. So we're going to actually kind of make a little pyramid. If we kind of stack our straws, what it's going to do is it prevents it from breaking out. Or we can add an arch, so we can take a straw and kind of bend it over the top. That may work. If we layer it too, we can make it stronger. Or last, if we make it into some sort of little triangle, which will be coming up in 1 second, we can actually make it, because we've done that stronger shape, the triangle. So that's that right there. Bridge help. So here's some help on how to make your bridge more successful. So we're going to go over a few things in a second. But the bridges is just going to be a little bit of help, like I said, how to make it better. So let's find the shapes. These are real bridges. So in here, we have a bridge. Well, Mr. Beuthin, I don't see triangles, and I don't see the arches and things along those lines. How can I make this? Well, right over here, there actually is at least 2 arches. If you look, there's that top arch and the bottom arch, and there's lots of triangles. There's triangles all across this bridge. That's why that's better. So a little bit of inspiration for you. I pulled these few bridges off the internet for you. So it's just kind of cool little bridges to make you start getting fun and thinking of the project. One has they have some cables on the top one, and this cables on the right one. It just looks cool. And that bottom one over there has just this weird funky shape with lots of triangles. So next, what is this? Think about it for a second, you guys. This is a very, 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 very old structure. And if you notice those arches in there, I wish I had the statistic off the top of my head of how old this is. But if you didn't know, this is the Roman aqueducts. It's one of these great feats of engineering. And what happens is this was built thousands of years ago, or hundreds of years ago, maybe thousands. I don't know off the top of my head, but you notice that arch, even back then, they knew that this arch was a strong shape. This has been around for years and years and years, and it's withstood the test of time. So use them as an example. Arches will hold its weight. So again, some more inspirational bridges. So we have, if you notice, the wood bridges, they tend to use less of the arches and more of the triangles in there. That top left one, you have some triangles. The top right one has triangles, and the old stone bridges have arches, and it's just how you build them. It's not saying that this is only the way to build it, but also to look at our final project. At the end, you got to remember, our bridges are being made to destroy. They are going to break, they are going to fail, but you want them to fail with the most weight possible. But at the end of the day, they're going to break. So don't spend a long time doing this little tiny the little tiny, like little special areas that, oh, this is going to be so cool. Because at the end, you're going to break them. They're all going to break. So don't spend a lot of time doing those fine details, because the fine details may not help you. Remember, stick to that geometry, and that geometry is what will help you make a bridge more successful or less successful. But this is also the fun part of the project, watching the bridges snap and break at the end. But to recap, groups of 2 and 3, there's a whole bunch of rules you got to follow. You get 50 straws. There's little stuff here and there, but it's going to be fun. You're going to make a bridge. Try to use those geometric shapes, those arches, those triangles. The less squares, the better, because the squares will actually tend to fall over like that first one did, or collapse in the center. But let's see. Use some examples that I kind of gave you over there of why bridges are good. And then let's see what else we need to do. That's basically your good recap. You guys have a lot of information. You'll have a lot of fun on this. And also remember, too, that the winning group gets a candy bar. So the group that holds the most weight will win the candy bar for this. The objective, the student will be able to use geometry to build a bridge. This will be done through group work, critical thinking, and a stress test. Good luck, you guys, and have fun.